Part 1, we're looking at the density of water. What we're going to do in these videos is you are going to measure your mass and your volume with me. We'll do it together. Make sure you have a data sheet ready to write down your observations and data, or somehow electronically if you wish. Okay, first thing we're going to do, we're going to weigh an empty graduated cylinder. This is a 10 milliliter graduated cylinder, good for measuring things up to 10 milliliters. What we're going to do first is we're going to measure this empty, and then we're going to play with our water for our density. When you put this on the scale, I'm seeing a weight of 21.07. What we're going to do now is we're going to add 10 milliliters of water. In order to measure our 10 milliliters of water, I'm going to get down and make sure I am at eye level to correctly measure to get the meniscus, right, the bottom of the bubble at the top. And we're going to make sure we have 10 milliliters. Notice we are using distilled water. Whenever doing any type of laboratory experiment or things of that nature, never use tap water, always use distilled water. Okay, let's measure out 10 milliliters. Oh yeah, I'm there. What we're going to do now is weigh the mass of our graduated cylinder with the water. I'm seeing 30.90. We have recorded our weight of the cylinder and then the weight of the cylinder and the water. If you take a look at the data sheet, you will notice that I have used units and I measured the weights of the water. So we have the mass, that's your weight. Make sure you subtract. Figure out what the volume would be. Remember, volume is the amount of space we take up. You're going to calculate mass divided by volume in order to get density. Once you get the density, this will be your calculated value for density of water. Then we're going to compare it to the actual value. How close are we to the theoretical number? Right? Are we getting close? Check in with the first video in order to get the actual density of water, or you can see that it's 1.00 grams per milliliter. We're going to do a calculation of percent error. What we're going to do is we're going to check in with your calculated value, meaning the one we got in the experiment, subtracted by the actual, that's the 1.00, divided by the actual. Again, this will be absolute value, meaning we will change it to a positive number no matter what we get. It's percentage. Let's times it by 100. This will give us our percent error, or the amount of space between what you got in the lab, what we got together, versus what we theoretically should have gotten. There is the density of water. We'll check out ethanol next.